TIS-100, which is a game by the amazing Zachtronics. Rather old game. The Tessellated Intelligence System Reference Manual. M. We are all still in shock here from Uncle Randy's sudden passing. While we wait on word from the examiner about the cause, we are coping as best we can. I've been occupying myself sorting through his things, especially his computers. Of course, I took one look in the garage and it all looks like a bunch of junk to me. I'll send some pictures when I get a chance. For now, this is the machine that was set up on his workbench when he died. Maybe you'll be able to figure out what he was doing with it. He would have liked to know someone was going to finish his work. Love, Aunt Doris. The pansies. Okay. Overview. The Tessellated Intelligence System is a massively parallel computer architecture comprised of non-uniformly interconnected, heterogeneous nodes. The Tessellated Intelligence System is ideal for applications requiring complex data stream processing, such as automated financial trading, bulk data collection, and civilian behavioral analysis. Notes like this one will appear in this manual to indicate scenarios requiring special attention and to refer to other documents that contain more information on a topic. All right. System architecture and organization. The Tessellated Intelligence System consists of a large number of independent nodes connected on a local basis. Refer to the model-specific manual to find the precise node population counts present on a particular device. Node types can be broadly classified as processing or storage, with several variants within each category. Generally, nodes are connected up to four neighbors via ports. Ports enable lightweight message passing communication between nodes. Communication over ports is coordinated by allowing either node to issue a read or write to a port and blocking until the request is filled by the corresponding node, and that blocking becomes a really big deal later on. I've played partway through this game before and never finished it. Note, if two nodes issue the same communication command, read or write, on the connection between them, the nodes will deadlock and a hardware fault will occur. Refer to the separate document, blah, blah, blah. If a node issues a communication command and it's never fulfilled, the node will deadlock and a hardware fault will occur. This document does not describe timing, blah, blah, blah. T20, reserved. Unauthorized requests for copies of documentation describing this node are reported to the State Security Bureau as required by law. All right. Basic execution node. Architecture. The base execution node is responsible for coordinating the behavior of the tessellated intelligence system. Processing can occur within the BEN or can be delegated to specialized processing and storage nodes. It executes a program specified in the instruction set. A node program specifies computational and communication operations to perform. Operations are performed sequentially, blah, blah, blah. After executing the last instruction, execution automatically continues to the first. All right. Contains a number of registered. They store integer values between -999 and 999 inclusive. ACC, type internal. The primary storage register. BAK or back. Internal. Cannot be read or written directly. You can only use save and swap. Nil. Reading nil produces the value 0. Writing to nil has no effect. Nil can be used as a destination, so it's like dev null, to execute an instruction for its side effects only, discarding the result. Left, right, up, and down are the ports. Any is the pseudo port. The first value that becomes available on any port. And last is the port last read or written using the any. Then we have the instruction set. And I'm going to dip back and forth into this. But we can have comments, we can have labels, no-ops, move, swap, save, add, sub, neg, jump. Jump if equal to 0. Jump if not 0. Jump if greater than 0. And jump if less than 0. And JRO is, I don't know what that stands for. Jump regardless of something. I don't know. Regardless of 0, maybe. Or read. The next instruction to execute will be determined by the value in ACC. Okay. And then some sample programs. I'm by no means an assembly language programmer, so this will be interesting. I do not claim to be good at this. Memory node. I don't think we have to deal with that right away. Random access memory node. To do. Figure out who sold TIS-100 to swap meet dealer. Rebuild signal multiplier. Look for book of micro optimization tips. Renew license plate tabs. Embedded interactive debugger. Control Z, Control Y, Control X, Control C, Control V, Control arrow, and view instruction set quick reference, view anti-tamper certificate status, certification status, begin running the current program, and step or pause. So F5, F6. Breakpoints, put an exclamation mark, good old tradition. Debug that would be too tedious to step through one instruction at a time. Cool. Visualization module. I don't think we have to deal with that right away. I like that the Aunt Doris letter is kind of bled through into the page. And that's it. That's all we get. So let's see what we can do here. I don't know how far I'm going to get, but we'll give it a crack. Yeah. Okay. Continue. Don't know what this sounds like. Someone will probably tell me. So some of these will have store. I don't know if I've gotten rid of them all. I think I have. Hopefully they're all gone. Create new program. Okay. Hopefully this isn't too small to be easily viewed. Read a value from in X, which is this, and write the value to out X, which is this. Read a value from in A and write the value to out A. And it's already completed this one for us. Move up, down, move up, down, move up, down. So this could be move up, left, move right, down, move right, down, no, up, down, move up, down, up, right, and move left, down. Now, we've also got these communication failure squares, and I see there's a debug here. Compute node diagnostic microcode dump. Can't find a pen right now, so I'm just going to take notes here. Looks like short-term storage. Got this one at the swap meet today. Fella wanted $450 for it, but I talked him down to $200. Good deal. No idea who makes this thing. Never heard of the TIS series. And the architecture doesn't look like anything I've seen before. Asked the guys down at the something or other, but no joy. Randy has a mystery on his hands. I guess Randy's the dead guy. Okay. So let's try running this. It runs its tests. Yeah, apparently it worked. Return to the segment list. Okay, so now we have this one available. Signal amplifier. Create new program. Read a value from in A, double the value, write the value to out A, which is down there. Okay, so double the value, huh? So I think this is going to be like moving it left and then retrieving that value and adding it. So let's say move ACC up ACC. Move ACC left. And then we would go move right back to right. So that should show up here. And then we would add left. So we would add the value from left to whatever was in ACC. And then move ACC down. And then sub ACC to return it to 0. So subtract its own value. And then this would be move up, down, move up, right, move left, down. Okay, let's step through this a sec just to see what happens. So the first instructions, move up ACC. We get 66 in. That goes into ACC, and then we move it left. Then it comes back to us. We add left, so we get 132. We move it down, and we subtract its own value so that it zeroes out. That seems right to me. Let's run it. Oh yeah, looks pretty happy. Carry on, running test 3. There we go. Continue editing the segment because debug. Continues to baffle. Chatted with Bernie at IBM. And he says it sounds like something they'd ONA come up with in the USSR. But then why is this manual in English? Wonder what happens if you pipe values into these. Return to the segment list. Okay, now we should have differential converter available. Sounds like something I wouldn't know how to do. Create a new program. Read values from NA and NB. Write NA minus NB to out P. And write NB minus NA to out N. Okay. So you have to subtract NB from NA and send the result here. And you have to subtract NA from NB and send the result here. What's in the debug? Interesting. It looks there's some kind of static memory in this thing, encoded something or other. Huh. Okay, so let's try it. First of all, we would mov up ACC and mov up ACC. And then mov ACC left, mov ACC right, so that we push the values towards the other side. We might not be able to do that at the same level. We might need to go down one, but let's, because it'll block. I'm just not quite sure. We have to sub. It'll be like sub AC, sub left ACC or sub ACC left. No, sub right and sub left, and then mov ACC down, mov ACC down, mov up down, mov up down, mov up down, and mov up down. I have no idea if this is going to work. Step through it a little bit. Okay, so we put the first number into ACC or ACC. Are we going to call it ACC? ACC. Move each number left and or right. So 4493. Sub. Ah, that's not working. Interesting. It's just blocked because I've put both in the port, maybe. It can't read because it's in write mode. Interesting. It's blocked until something clears that port. So I have to do this in the second level, basically. Okay, good. That's good to know. So we can do one of them. We'll do A first. Mov ACC left, mov ACC down. So this one will have the solution, but it will also need to deal with ooh, this is interesting. Because it has to do the subtraction and send it down to the output, but it also has to send its own value. Yeah. Should be able to do this. I just need to understand where. So we can immediately get the answer for this one. That's not a problem. So if we step through it, we'll see it happening. Oh no, we need to take that instruction out. You just take that out so that the port's not in write mode. So this is in run mode. And now this is in read and this one's in write. So that should be fine. Yeah. So minus 49 is the correct answer. but out in will end up being wrong because it's 93. So that's good. We can do 1, but we also need to be able to... I think probably what we might end up doing is of up ACC, and then we'll also do a save so that the value of ACK gets moved into ACK back. And then sub-right, move ACC down, swap to get this value again. And move that right. And then sub left, move ACC down. Yeah, I think that's right. Let's just check that. So we get 44 and 93 as our initial values. We save 44. We sub right, move it down, swap, and move that value right. Then we sub left. Did we do that already? Yeah. Move that value down. Okay, let's run that and see if we miss any. Oh yeah, nice. Seems to work. Okay. 393. Did someone do that in 250? Less than 250? Holy crap. How? I'm going to have to look at these later. Okay. Communication failure. Oh yeah, I saw this already. Cool. That Reddit's really hard to read. All right. Sweet. We made it. Return to the segment list. Signal comparator. Oh, both of these are open now. Okay. Create new program. Communication failure. Found a block of static memory, but it's in a proprietary format I never saw before. Can't make heads or tails of it. Oh, brother. There's just too many different kinds of machines coming out now. And I like tinkering with them as much as the next guy, but when every Tom, Dick, and Mary implements their own memory address scheme, it's all blah, 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 blah. I say the bottom's going to drop out of the microcomputer market soon. Mark my words. You're probably right. Okay. Read a value from N. Write 1. Oh, okay. Comparator. Write 1 to out G if N is greater than 0. Write 1 to out E if N is equal to 0. Write 1 to out L if N is less than 0. When a 1 is not written to an output, write a 0 instead. Okay. So everything else has got to have zeros. Oh man. And we can't go along here and down. We have to send our outputs down this way. Oof. I assume. So, yeah. So we have to decide, we have to make decisions here on the values. So it's going to be out G is going to be if n is greater than 0. Okay, so move, let's sketch this out. Move left ACC. Jump if equal to 0. No, wait a minute. Jump if greater than 0. True. And we'll create a true label. Mov 1 down. And then false. Mov 0 down. JMP. Is there a thing for just go to the start? Or do you have to label it? I think you have to label it. So we'll call this start or begin. JMP begin. False. And that'll just go straight back to the beginning. JG0 looks like it's a problem. I thought that was what it was. Oh, JGZ. That's what it is. Okay, so false is move 0 down and then move ACC right. Actually, we have to move ACC right anyway. So this is move left ACC, move ACC right. Yeah. So this is probably just going to be move up, down, move up, down, move up, right, and then, yeah. And so the rest of the structure should be pretty similar, right? Begin, move left ACC, move ACC right, J equals to 0, true, true, Mov 1 down, jump begin, false, Mov 0 down. And then this is begin, Mov left, ACC, J, LZ, true, true, Mov 1 down, JMP begin, false, Mov 0 down. Okay, that to me that looks right, but I'm not sure. So let's just play it out. It might also not be the most efficient way of doing it. Okay, 2 is going to move into the queue. So 2 is greater than 0, so this should be true. Moves 1 down and goes back to the beginning. Okay, we've already failed. Oh, I see what's happened. Okay, so even though we've got these blocks here, we have to also jump to false. So this one has to be JMP false, and so does this, and so does this. Okay. Or actually, there's no need to have a false block at all. When you look at it, MOV 0 down. We're refactoring already. MOV 0 down. MOV 0 down. Can you mouse select? Oh, cool. Okay. So that looks a bit simpler. And we don't need jump begin anymore now. Yeah, much better. All right, I'm reasonably happy to run that. Oh, no. No, stop. Oh, that was bad. Okay. Yeah, not good. I hope that wasn't too loud. I have no idea what the volume's like. Okay, so step through this. Okay, 1 is correct. J equal to 0, MOV 0 down. Okay, so the first one was correct. The second one failed. So J equal to 0, true. That's weird. What I need to watch that again. I didn't see it come in. The first one was right. So MOV ACC right. Yep. J equal to 0, true. But it isn't. Oh, I see. Yeah, we do need a loop instruction here. Okay. JMP begin. JMP begin and JMP begin. Okay, try again. Now we're talking. That's a lot happier. Much happier. All right. Looks like most people are able to do that with pretty similar levels of instructions, so that's good. Return to the segment list. Okay, we're getting through a few of them, a few of the basics. Now the multiplexer. I feel like it's trying to teach us how to do some of this basic stuff, and then the final ones will be ridiculously difficult. Communication failure, debug. I might have an idea of where this TIS-100 machine came from. Described the architecture to Fred at Motorola, and he says it sounds like it was designed for signal processing. That got my brain going. Government project maybe. Something the CIA cooked up to comb through Soviet radio signals. Hush hush, top secret. Maybe. Could I be in possession of a classified device? Something for spooks. I might have to sit on this one for a little while. Read values from NA and NB. Read a value from NS. Write NA when NS is -1. Write NB when NS is 1. Write NA plus NB when NS is 0. Okay. Okay. All right. So roughly what my brain is doing right now is saying there's 3 different decisions to make about an S, so that we should use these 3 slots. And we should pass in these values each time and just make decisions about which one we use. So let's go with mov up ACC, mov ACC right, and mov ACC down. Mov up ACC, mov ACC, excuse me, mov ACC left, mov ACC down. And then the first decision to make is but see, how do I get the output there? I don't think my design works. Or does it? Does it work? So let's think about this. If we have the values on either side and we make a calculation based on I don't know about this down. Can we do it all at one level? I feel like we can't. But let's try and map it out. So the different blocks would be neg, pause, and 0. In 0's case, we would write NA plus NB. So mov left ACC, add right, mov ACC down. In the positive case, it would be mov right down and sub left, or can you just consume? You can just consume a value, right? Sub won't work. I think you could move it. You could, you could move it to ACC. Just to clear it, basically, or discard it. And then in this case, it would be mov left down and mov right ACC. And then, but I think you'll run out of space if you try and do it all in one block, because we've only got a certain number of instructions available. And after each one of these, you've got to jump begin. So I don't think there's going to be space. So it would be mov up ACC, JEZ 0, and that's all the space you've got. Yeah. I don't think it works to do it all at one level. But that's essentially the program. And then you would just add J, G, Z, and JLZ. Could I do it in less instructions, maybe? Surely I could. Or do I need to make use of all of these other wonderful nodes that are just sitting there waiting to be used? Surely I could make use of all these nodes. But how? So I've got to, if I do it that way, I've got to persist the value that's coming in via NS somehow. Yeah, I don't quite understand how to do that. I'm sure I've solved this before because I've been further than this in the program. So I just need to think about it again. It's been several years. I wonder if it's these instructions that are consuming. Maybe rather than moving the values from B and A into this column, we move the values from this column into A and B. Maybe that would be a more sensible approach. So let's pursue that. And then we can make the values available at each level if we need to. The only trouble is the addition phase. I suspect we might have to be how do I do this? Read values from NA and NB, read a value from NS. Right, yeah. There probably is a very smart way to do it all in one box, but I don't think I'm that smart. So let's start by refactoring out so that move up ACC, move ACC left, move ACC right. And then we won't do these. I might be able to do it by timing, so that the first one to get it there wins, kind of thing. So that if this is, for example, positive, then we immediately write this to the output channel. So this becomes MOV up, down, MOV up, down, and MOV right, down. I don't think this is going to work. I'm just kind of riffing on it for a minute. Save. MOV left ACC. J. GZ. True. True. Swap. MOV ACC down. Yeah. And then this becomes begin and jump begin. All right. So that fulfills one side, essentially. So that if we step through it, yeah, it never gets there. Wait a minute. Stop. Is the first case greater than 0? No. So we need to implement this side. Begin. MOV up ACC. Save. MOV right ACC. JLZ. True. Jump begin. True. Swap. MOV ACC down. MOV up down. MOV up right. And then we're stuck, so we'll just say MOV left down. Okay, so the first value is negative. JLZ, true. Swap. MOV ACC down. And negative 13 goes out, and the first case passes. And then everything else dies. Although, yeah, in theory it kind of works. It's just this bit at the bottom that's not so great. And the need to add the two values together. So how do I add the two values together and still retain actually, if we could have them all arrive at the bottom, and then you could use the what is it called? The port that takes the first one. The first available one. Any. Right, so this becomes mov any down. And then you would have to JGZ true. The trouble is that will fail. That'll start to fail. This is hard. I must have figured this out at some point. But it's okay. It's just a question of time. It's just a question of time. We know how to write the program if we can put it all in one node, but we can't because we don't have room. We don't have enough instructions. Don't have space for enough instructions. So we need to deal with the case when we need to add them both together. It looks to me like, I was going to say almost all the values coming in on A and B are non-0 or 1, but some of them are 0 and 1. So you can't cheat that way. You should never rely on an edge case anyway. So how do I do this? I think I need to wipe most of this out because it's just distracting me now. What about storing the value? What if we get the value for mov up ACC, mov ACC right, mov up ACC, mov ACC left, mov left ACC, add right, save, mov up ACC. I think we will do mov any down. And we'll try and make it so that only one message at a time will ever get, only the right answer will ever get to this box. That's going to be our goal. Yeah, that's going to be our goal. So I've now got the added total of these two saved in here. So let's step it through to that stage. Okay, so I've got -6 and -1. So we can say J EZ out. Out is swap mov ACC down. And this is mov up down. This is jump begin. Begin. Okay, so that takes care of the situation where NS is 0. For the situations where it's not, wait a minute, isn't there a situation where JRO depends on whatever's in the next thing? Whatever's in the ACC. Transfer execution unconditionally. Okay. JRO 2. JRO -1. Previous instruction will be executed next. Okay. Can I use that? No, because I need, well, maybe because I wouldn't have to rely about labels. I wouldn't have to rely on labels. I might be able to squeeze enough in for it to actually work. So in theory, I could execute stuff based on the value in there. So hang on, let's just think about this. JRO ACC. So if it's -1, it's going to execute the previous statement. Hang on. JRO 2. JRO ACC. If it's -1, it's going to execute this line. So that's going to be mov ACC left. Jump begin. This is not going to work, is it? I don't know. Hang on. JRACC. If it's 0, what would it execute? Nothing. Okay, no, that's definitely not going to work, although it's interesting. Okay, so JEZ. Out. Out. Yeah. Hang on, let's just see if we can do it. JEZ out, JGZ. GT. Mov. ACC right. Jump begin. And then less than, it would be mov ACC left, jump begin. And I'm right out of room. Well and truly out of room. You can't squeeze it all into one. Doesn't work. Oh, man. Okay. I've done this before. I can do it again. Done it before. I can do it again. Add right. Save. What about if after that, mov up ACC, what about if I move the value that I've just read, ACC left, mov ACC right, and then JEZ out, jump begin. Out is swap and mov ACC down. Okay. So that offloads the ability, that offloads the decision making onto these columns. So in this case, we've got mov ACC right, swap, or no, actually save, mov right ACC, jump, less than 0, yeah, jump less than 0, out, out, swap, mov ACC down, mov up down, mov up right. Same deal here. Save, mov left ACC, JGZ out. Swap, mov ACC down. Mov, I think we're onto something. I think we're onto something. I think we might be onto something. Let's figure this out. Okay, so our first value. Oh, hang on. This has got to have a begin. Otherwise, execution will fall straight through. Jump, begin. Okay. Let's try this again. We get all the first values, and for the record, the first value should be out minus 13. So in other words, A should go out. So we pass the values off to the other side. It looks like A is all set to output its column, which is good. Minus 13, minus 13, and that succeeds. And then in the second case, looks like we're outputting from the other side. Yeah, I think we might have solved it. Let's run it. Ah, look at it go. Look at it go. Look at it go. Sweet. Nice one. I doubt if it's the most efficient thing ever, but it works. All right. Very cool. But apparently my cycle count is well off the charts compared to most people. So there must be an easier way to do it that I'm missing. Interesting. I suppose, could I have just redirected it all into the middle? Maybe. Anyway, I did bad, but that's okay. I still won. Sequence generator. Okay. Sequences are zero terminated. Read values from NA and NB. Write the lesser value to out. Write the greater value to out. And then write 0 to end the sequence. So it's a sort, essentially. Okay. Communication failure. Debug. The new girlfriend is encouraging me to get rid of the microcomputers I've accumulated over the years. Not a bad idea. Most of them are just taking up space and aren't doing me or her any good. Going to wait on this one, though. Never found out what its whole deal was, and if it turns out to be something I wasn't supposed to have, I think I could get in trouble. Cleared a little space on the workbench and hooked it up. Still works. Beautiful. Yes, it is a beauty, this one. Okay. So, is it a CIA computer? Who can say? All right. Read values from NA and NB. Write the lesser value to out. Write the greater value to out. And then write 0 to end the sequence. All right. Okay. How do you determine greater than? You subtract one from the other. If the value is less than 0, then the first value was greater. If the value is greater than 0, then the second value is greater. And if it's 0, then they're equal. All right, let's just roughly sketch it out. Let's assume mov up right, mov up ACC, save, sub left, J LZ A greater if A is greater, then we need the value of A, which we don't have anymore. Okay, so mov 1 left. Actually, can we send it twice? Mov right ACC right, and then do it again. So there's 2 copies of each one. Does that make sense, or is that stupid? Swap mov ACC down, mov left down, mov 0 down. Oh, that should be the last one in any case. Oh, let's try repeating it for now, but I don't think we're going to have space. B greater than mov left down, mov. Oh, we're still going to need to swap ACC down and mov 0 down. Yeah, this isn't going to work, but that's the general idea. That is the general idea. How? It feels like we should do it quite similar to the way we did the last one. Wait, why does YouTube think it's looking at my editor? That's weird. Is the YouTube stream a really long way behind again? Or just completely disconnected? What does Twitch think it's looking at? It's so weird. I think it's just a really long way behind. Bizarre. Oh well. I suppose I can always just look at Twitch. Oh yeah, it's definitely looking at the game screen. Okay. All right, so how do I do this? I've got to determine which one is greater. Probably in this one. And then maybe construct the actual output in the next one. Does that make a certain kind of weird sense? Let's see. Begin. If A is greater, mov -1 down. B is greater, mov, or actually in all other cases, since it doesn't seem to matter what you do if they're equal, mov 1 down. Well, actually, just it's a binary choice, right? Yeah. So we just go true, false. It's not really true and false, but I don't care. Jump begin. And then JLZ A greater, JLZ true, JGZ false, or actually in all other cases, mov 0 down. JMP begin. Okay, but we also need to retain the value of B. So swap mov ACC right, and that should be it. So this is now mov left down, mov up left. And then we need some logic in here. Mov ACC right, and then we don't need it twice anymore. Mov ACC down, mov up right. So here we've got mov up ACC, save, sub left, JLZ true, mov 0 down, swap. Well, actually, we still need mov ACC right. We always need to do that. So mov up ACC, mov ACC right. So we don't need save anymore. Sub left, JLZ true, mov 0 down, and then we can get rid of this. Jump begin. That becomes a little bit simpler. And we don't need this. Okay. So we're telling it what the order is, essentially. Mov up ACC, JGZ, A, begin, and then I guess the rest of the default. So we don't need a B. So it's going to be move right down, move left down, move 0 down, jump begin. And this is going to be move left down, move right down, move 0 down, jump begin. Well, not that last part. All right, so is that actually correct? So we're going to get a 1 if this is less than 0. We're going to get a 1 if sub left. We're going to get a 1 if left is greater than right. So actually this should be the other way around, I think. Yeah. I think that might be it. Let's step through it and see what happens. Okay, so now we're going to move left down and then right. So so far that looks correct. Yeah, I think I might have eventually stumbled on the right answer. Hey, look at that. It's just buzzing along like a buzzy thing. And I'm in the median, apparently, except for instruction count. Okay. All right. We gradually got there. Apparently I've opened up all of these. Oh, and there must be a saved one from there. User segments, simple sandbox. Don't know what the deal is there. Create new program. Sequence counter. Sequences are 0 terminated. Read a sequence from in, write the sum to out S, and write the length to out L. Oh, okay. Huh. So basically every time you read something, you're going to want to send a counter and just keep incrementing it. All right. Well, we could write the counter first, I suppose. So move left. Wait. Yeah, move left ACC. J E Z and so we've arrived at the end of a sequence. Swap, move ACC down, move ACC down, oh, move up, down, and move up, down. Otherwise, otherwise what? Otherwise, add 1 to our counter. So swap, add 1, save, jump, begin. I love all the little programming he would have had to implement behind the scenes. I wonder if he actually implemented his own, like, chipset. Okay, MOV left ACC. Cool. I think that counter works. So we need to MOV up ACC, MOV ACC right. And then we need to write the sum. JEZ int swap move ACC down. So we've got an incrementing value that we're saving essentially. This is going to be jump begin, and then in here we need to do the addition. So we know the value we've just put in ACC is not 0, so we'll move it left and then add left. Save. And then over here, we'll just go move left, move right, right, if that makes sense. So this is like an echo. And then this is move up, down, move up, down. Okay, let's see where we get to. Oh, hang on, we're already wrong. Which operand are you missing? Oh, this one? Yeah, it should be move ACC left. Okay. Oh, we're already wrong. Okay, how do we get 70? Oh, I see. So you shouldn't... yeah. So I've accidentally doubled it, basically. How did I manage that? Let's run that again real quick. Move up ACC. Move ACC right. If it's equal to 0, go to end, which it's not. Move ACC left. And then add left. Okay, so I added it to itself. That's not good. I think I need a swap in there somewhere. I think I need swap here. Add left, save, yeah. So in the first call it'll be 0, but then otherwise it'll be the accumulator. Okay, let's try that. Okay, looks like it's going to output 35, so that's good. It's output 260. Okay, I'm happy to run that. Oh, yeah. Oh, getting the hang of this. I get the feeling it's just going to ramp up. Like, I think this is close to where I got to the last time, which is maybe why some of these feel a bit familiar. So yeah, it's probably going to get harder. Huh. Seems to me. Okay, we hit kind of median by the looks of things. We didn't do too badly on the instruction count. How did someone do it in like 14 or whatever that is? Oh wait, is this comparing? This is comparing to other people, right? Or is this just the test runs? No, it's comparing to other people, I think. Anyway, did I look at the debug? Oh, I didn't. Okay. No, she won't understand. Of course she doesn't. Why would you expect her to? Just keep working. I feel like I'm learning about the people behind this and their design decisions, the thoughts that went into figuring out how things should work. Those people feel very close to me now. Okay. So we're up to signal edge detector. Read a value from in, compare value to previous value. Write 1 if changed by 10 or more. If not true, write 0 instead. The first output is always 0. I feel like that's going to become important for some reason. Edge detector. Compare value to previous value. Write 1 if changed by 10 or more. So I have to store... I have to be able to subtract 10 and then see which is greater, that value or the change. If not true, write 0 instead. First output is always 0. Okay. Okay. So I need to store the previous value. That's first and foremost. I could use either side as the storage for the previous value. Okay, let's just sketch this out. First of all, we'll do mov right, right. And then we'll go... If we make this just responsible for subtracting 10, and then because we don't ever have to retain the value after that. So mov up ACC, and then the last thing is going to be what is the last thing going to be? We're storing the value on the left. So mov ACC left. Maybe I should sub 10 over here. I mean, we can depend on the first value being 0, so we could just skip if it is the first read, right? It might be a wasteful way of doing it, but let's just see how that plays out. So J, EZ, skip, essentially a no-op. And then sub left. Don't know how this will work with negatives. If it's changed by 10 or more, but does that mean 10 negative or positive, right? So it's the absolute value of the change. How do you determine absolute value when you don't have an abs? You just flip the sign, huh? Just flip the sign. No, you just compare them, compare the difference. So, I think I understand what I would do if it was always positive. So I should be able to extrapolate from there, but let's just see. Sub left gives me, say I've got 10 coming in as the second value and I'm subtracting 10, I get 0. Sub left gives me the difference between the two values, but I need the original value. So I need save. Sub left. If the difference is 10 or more, God, how do I do that? I do not understand. I do not completely understand. How would I calculate absolute value? Or do I need, I do need to calculate absolute value, don't I? What's the formula for absolute value if you spell it out? Huh. Right, 1 if changed by 10 or more. So the other thing I need to do is subtract 10 from it and see if the values are equivalent. We'll see which one is less, right? Right, so I would need to add 10 to the result of that subtraction and see if it was less than or greater than the original value. Right? Huh. Yeah, because you want to subtract 1 from the other, and then you want to add back 10, and you want to compare the result of that with the original value and see if it's less, then the value is changed by more than 10. If it's greater, the value is changed by less than 10. And if it's equal, the value is changed by exactly 10. Yeah. I do believe that is correct. But we don't need the original value anymore after that. Okay, while I'm thinking about that, let's read the debug. Days and days and days, cycles and cycles, just one after another. I'm sick and tired of people who don't respect me. Time to pack it up. Oh, sounds like it's getting serious. Okay, it's getting real. But so I could move the result of that subtraction right. And then I could swap and move ACC right again. Okay, so this is first sub result, then original. Yeah. Except actually you want, instead of the current value, you want the first value, because you want the degree of change. So what if we do this? Mov right ACC, and we use this value twice. ACC right, mov ACC right. And then this is oh, wait a minute. So in the example, if you go 10 minus 0, it's going to be 10. You compare that with 10, and you have a degree of change of 10. So no, we do want the second value, not the first one, I think. So we'll just use this as an echo box, and then this is mov ACC right, swap mov ACC right. So to get the original value back, jump again. Okay. Then, so it's first the sub result, then the second operand. So mov left, ACC. So that gets us the subtraction result. And then we go sub 10, sub left. Should get us the difference between the two. Oh no, we need to sub 10, right? That's or add 10. Add 10? I need to see this working. My brain is not capable. Save. Mov left ACC. Oh, this is so hard. I need to see it on paper. I need to know how to do the actual math. So, if we've got the first two values is 0 and 10. So we go we're skipping it for the first. Actually, that's probably a bad idea. Oh no, that's right. I don't know. Let's say we've got 5 and 10. We subtract, it then becomes 10 minus 5, and we get 5. And then we've got 5 is stored, and we've saved 10. So in the ACC has 5. Back has 10. And then we've got, we move 5 to the right hand side. So we store 5 in ACC, and then we add 10 to it. Then we store that. So the ACC has 15 and back has 15. Then we take the next operand from the left, which will be the original, the second parameter, so 10, right? Oh God, this is painful. How do I do this? Of ACC right. So let's just see what values are going where. We skip the save. Actually, I don't think there's any need to skip. I don't think that's necessary. Let's see if it is or not. So 0 moves left, then we save it, we sub left and we get 0, move ACC right, swap, and move ACC right. Now over here we've added 10, and we save, move left ACC, so we've got 0. Yeah, that's not right. I think what I want to do is subtract 10 from the result of the first sub. But the trouble is I don't know how to handle the sign. How do I handle the sign? I mean, all my positive cases will work, so maybe I should do that first. So let's take the second case. You've got 32 coming in. And you subtract the previous one. That's what it's supposed to do, right? compare value to previous value. Write 1 if changed by 10 or more. So in this case, we would go 0 minus 32. We could just add it, right? If we did 0 minus 32, then we'd get negative 32. Save that value. And compare it to 0 minus 10. So we've got two values, minus 10 and minus 32. If we subtract minus 32, if we subtract minus 10 from minus 32, we get positive 22, right? Math. Minus 10 minus 32, what is that? Yeah. I wasn't going completely around the bend. So we end up with 22. And we compare that we subtract 10 from that. If the result is f greater than 0, change true. F greater than or equal to 0. So if equals 0, true. If less than 0, false. I think that's what we're looking for. What happens if, hang on, where did I get negative 10 from? So it was 0 minus 32 is negative 32. And then negative 32 minus negative 10, or negative 32 minus 10 is negative 42, right? So tricky. I think I'm getting wrapped around the sign. What happens if you take the second value and subtract the first value? In that simple case, it would be 32 minus 0 equals 32. 32 minus 10 equals 22. If greater than 0, true. If equals 0, true. If less than 0, false. Yeah. Now, in the second case, we would have 30 minus 32 equals negative 2. Negative 2 minus 10 equals negative 12. if greater than 0, true. So it all kind of works, but only accidentally. I think. Let's take another case. (27) minus 30 equals -3. -3 minus 10 equals -13. So that all works as well. Oh, no, it doesn't. Because you're going to... Yeah. No. It's less than 0, so it'll be false. So let's take a value where it has changed, but the answer will be negative. If it's changed by 10. 33 to 24. 33 minus 24 equals what? Oh no, that doesn't work. Where's a better case? 19 and 9? No. Oh yeah, that works. So 19 minus 9 equals 10. 9 minus 10 equals -1. No, it doesn't work. I think you have to add it. You have to reverse the operation for it to work. (19 minus 9 is 10. And the result of that, so you go 10 minus 10 equals 0. And then you go if greater than 0, true. Yeah, that one works. But what if you've got, if 1 minus 9 equals -8. -8 minus 10 equals -18, right? I'm getting wrapped around the axle by this, man. Completely. I might need some help. Have I not done this one before? I need to understand how to do the actual problem before I can implement it in goddamn assembly language. And I need to understand how it works with a sign. So that's okay. Just need to keep it in our head that it doesn't matter how long it takes us. That's all it is. It doesn't matter how long it takes, as long as we understand it. So let's take 32 minus 30. Equals 2. (2 minus 10 equals -8. So val less than 0. change not greater than 10. Okay. Let's take another case. 3 minus 14 equals negative, what? 11? Negative 11 minus 10 is negative 21. The change is greater than 10. In a negative direction. Do I need to test the positive direction and then the negative direction? And if either one of them is true, then we write 1. Huh. Well, that could work. So how would that look? Two plus 10 is 12. No, we need to add it to the original value. So 32 plus 10 is 42. But it makes no sense for, if you subtracted, you need to subtract by a known value. 22. And then you subtract 22 minus 2 is 20. Wait. You need to establish whether 2 is greater than 22 or not. Ugh. This is basically, how do you implement a greater than sign in binary in assembler? Wasn't this one of the examples? No, it's a positive negative test. Although we could actually use this. Yeah. So like deal with positive values, deal with negative values. I bet some people can just solve this instantaneously. That's okay. That's not what we're here for. We're here to figure this out. Okay. So, how do I deal with the case where the change is less than 10? So we want to determine, I think we would want first result minus second result. Actually, couldn't we just subtract 10 from 2? Yeah. So 2 minus 10 equals negative 8. Greater than 0 is true. Greater than equal to 0 is true. Less than 0 is false. Excuse me. That's the case where the original value was positive, right? If the original value is negative, or if the first result is negative, then that doesn't help us. Because, so we've got 5 minus 20. You can't just go negative 15 minus 10 equals, because it won't. Yeah, we'd have to add it. Plus 10 equals negative 5. And then this is true. Okay, we're getting somewhere, I think. So we need to determine whether the result is negative or positive, which I think is probably why they gave us that piece of sample code. Okay, so the first task is to subtract one from the other and put the result in the next block, basically. Okay, let's keep this so that we don't get thoroughly confused. And then we'll go mov. Oh, I'm excited now. I think we got it. I think we got it. We're slow, but we get there. Mov up ACC. Mov left, ACC left. We'll echo that back. Mov right, right. Mov up ACC. Man, the YouTube stream is a long way behind. I wonder what's up with that. Hey, Ahmed Maloud, how you doing? Be warned, I'm struggling through TIS-100. It's kind of slow. Okay, so move the second value into ACC, and then we go sub left. And that gets us a number. And we move the results. Now hang on, we always need to retain the previous result. What is this diagram about? This is a game by Zachtronics called TIS-100. And it's a very old game where you've inherited this ancient computer system and you need to kind of pick it to pieces and repair it and try to understand why it was put together and what it's for and the mystery behind it. It's on Steam and probably relatively cheap. It's a good little game. Anyway, that's where it is, and I have never finished it, so I'm trying to work my way through it. But it's hard for people like me with very little brains, so I am just doing it step by step. So I always need to retain the previous result. So we should store mov ACC left, save, mov up ACC, sub left, mov ACC down, and then we've done our job. So we actually don't need this first line. Mov up ACC, sub left, mov ACC down, swap. Does that sound right? Let's just see what that does for the first few iterations. Actually, we'll just mov up, down, just to clear the result. So step, mov the first one left, save, mov up ACC. Oh. So this, is that right? Sub left, mov ACC down, swap. I think I've got that wrong. So 32 minus 0, yep. It's 32. Move it down. That might be good enough to continue with. So the whole point is that now we need a negative or a positive detector. Neg pos. And we already have one of those because they provided it to us in the manual. Let's see here. There it is. I can't copy out of it, of course. All right, cool. So let's see if we can re-implement that. Mov up ACC. JLZ, or jump less than 0. Neg. JGZ, jump greater than 0, pos, and equal to 0, I'm not quite sure yet. So neg is oh yeah, there we go. If it's negative, we need to follow this one and add 10. If it's positive, we need to follow this one and subtract 10. Okay. Yeah, so if it's negative, we need to add 10. Mov ACC. Oh no, actually. Jump out. Sub 10. And then out is mov ACC down. And yeah, this one will determine what gets written. What do we do if it's equal to 0? 10 or more. If it's 0, would we want to add? No, if it's 0, we'd want to subtract. Because well, actually, if it's exactly 0, I don't know. What happens if it's 0? So it would be like 0 minus 10 equals negative 10. No, it doesn't work. 0 plus 10 is 10. It's greater than 0, it's true. I think if it's 0, oh, I don't know what to do if it's 0. So the ways in which you could reach 0 would be like 32 minus 32 is 0, or 2 minus 2 is 0. In the first case, we should return true. In the second case, we should return false. Damn it. I don't know how to do that. Maybe my whole system's wrong. Are there any situations where two numbers occur the same? I genuinely don't know. I'm sure there will be a situation like that and it'll fail. Let's try and get the first part of it working first, and then we can figure out what to do about the special case. JMP out. Okay. All right. So move ACC left, save, move up ACC. So down here we have to implement the logic. So move up ACC, J greater than 0, true, J equal to 0, true, otherwise move 0 right, JMP begin, true, move 1 right, move left down. Okay, this is all gonna fall in a huge heap. Okay, so 32 is coming in. It's going to write a 0. Okay, so I think the default for this for the 0, 1 is wrong. So let's assume that, let's try pos. I'm not quite sure what to do with 0. J equal to 0, pos. Those are the only 3 options, so we don't need that anymore. And we'll just see what happens. Or I could just not send the 0, but I think it needs one. Okay, so that passes. No. All right. So, not quite, but more promising than anything we've had before. Okay. Hard. So, is the output coming through from the top one, correct? Okay, so we've got -10. Why? Why do we have -10? Oh, because it was 0, sub 10. All right. Then we've got 22. Why do we have 22? Why do we have 22? Yeah, I don't understand that. Let's look at what's happening in the top box here. Oh, whoops. We save, we move up to ACC, we sub left. So it becomes 30. I'll move ACC down. Yep. And swap. Then we move that left again, so we keep the previous value. Then we save. Don't know if that's necessary. We move 32, and then we sub the previous value, and we move everything down. So 32 arrives in this block. And it was greater than 0, so we sent it to positive, and we sub 10, so we get 22. Then we move it down. If it's greater than 0, which it is, we move it true. And that's correct. Then we got 30. Which has been sent down already, and I think that's wrong. Yeah, that should not be there. I think this top block is wrong. So, I don't know about the save. Move up ACC. Move ACC left. Hang on. Move up ACC. Save. To store it for next iteration. Move ACC left. The first one's always 0. Maybe I should just skip the first one. No, I can't skip it because I need it to output 0. Or I could just do that. Move up ACC, save. Move ACC left. We can't do that straight away or it'll overwrite the previous one. And we can't sub left if there's no value there. So actually what we need is a swap first up, which I think is why I had it there. Swap to get the 0 out of back. Move ACC left. And then move up ACC. Save. Sub left. Yeah, so this gets the previous value, or 0 in this case. And then we get the next value and save it. Then we sub left, move ACC down, but we don't put a swap there. Okay, I think that might be right. Okay. Then we get 32 minus 0 should be 32 coming down, which it is, and then it becomes 22. And then we should get 2 moving down, I hope. Or negative 2. 32 minus 30, no, that's wrong. Damn. Why is that happening? I'm actually going 30 minus 32. Oh, I suppose that's right. Is it? No, it's not. We should be getting 2, not negative 2, but either way, it would have been nice to know why. The difference was the same, so it'd be nice to know why that failed. So we swap, we get 0, move ACC left, so 0 goes that way. Move up ACC, so 32 goes that way. Oh no, 0 goes that way to begin with, so it's 0 minus 0, 0. All right. Then we swap, we get 32. So actually the value that's in, the value that's in the back should go left, which it does. Move up ACC, save, sub left. So the new one subtracts from the old one. Move down. So it should be 32 minus 30. Let's just watch what value goes left. 0, 0, 32, right, so we're subtracting 32 from 30. So -2, add 10 is +8. Yeah, this is wrong. It's close, but it's not right. Damn it. So the case is the case is 32 minus 30 equals -2. -2 plus 10 equals 8. The change was 2. So this greater than 0 is true thing doesn't work. Okay. I need to understand how to implement difference without greater than less than. Well, I have greater than less than, but only of 0. Okay, so this is a ChatGPT question. How does one implement the difference between two numbers with only minimal mathematical operations, e.g. subtraction and addition? No. My bad. I meant how to determine if a value has changed by more than 10 in either direction. Yeah, but I don't have absolute value. Assume abs is not available. Yeah, so difference is new value minus old value. If difference greater than 10 or difference less than 10, return true. Assume that greater than and less than are also not available in a minimal assembly language environment. Difference between numbers. Check if the difference is outside the range. Yeah, so this is essentially what we're trying to do already. But I feel that I misunderstood it. New value minus old value. If difference minus 10 is greater than 0, return true. Right. So you need to do both, in other words. Not just one or the other. I think that's probably the piece of the puzzle that I'm missing. So let's see if that's true. So for our test case, right, we're going the wrong way. If difference plus 10 is less than 0, we're true. So this becomes less than 0, true. Greater than 0, false. Equals 0, false. Wait, equals 0 will be true, wouldn't it? And then we go minus 2 minus 10 equals negative 12. And we're saying if it's greater than 0, true, less than 0, false, and equals 0, true. Okay, I think I get it now. But it definitely took seeing it on paper to understand. Okay, this is hard for me, for my bare of little brain, but we'll get there. So this is giving us the result of the subtraction operation. However, doing this is not enough. We need to output we need to add 10 and output the result right, and add 10 and subtract 10 and output the result down, I think would be the way to go. So mov up ACC, add 10, oh no wait, save, add 10, mov ACC right. So this is add 10. Actually, you don't need to save. You can just sub 20. Sub 20. Mov ACC down. Sub 10. Okay. Good. So in this case, mov left ACC. In the add tune case, less than 0 is true, greater than 0 is false, and equal 0 is true. JEZ true, JGZ true. Yeah. And this is going to be mov any down. True is mov 1 down. Question is, how do we know to write the 0? I think I might need another box. Oh boy. Could I do it all in one box? Probably not, right? Yeah, probably not. So I might need one of these extra boxes. Let's see here. Because we know how to find true, but we can't output a 0 unless both of those boxes are false. So I do think that means we need to go in another direction. So we'll move things around. I don't think this is accurate any longer. This one is going to be mov up ACC. JEZ true. This is actually less than 0. Oh no, hang on. This one is less than 0. JGZ true. And then I'll label true. Mov 1 right. Mov 1 down. Begin. Jump begin. begin, jump, begin. All right, now we need to determine if either of these ones are 1, and if not, we output a 0. So mov up. Oh, so we need to output a 0. In other words, mov 0 down, jump, begin. Mov 0 down. Mov up ACC. J, G, Z, true. So this is like combining the two results essentially. An XOR, an XAND. Mov 1 down, and this is mov up right, left rather, and this is mov right down. Okay. Mov left ACC, JGZ true, mov 0 down, jump, begin. Okay, what have we wrought? What have we wrought? Let's try it. Okay, so 0 is moving to the right. Oh, this is wrong, because it used to be in a different spot. Add 10, sub 20, yeah. All right, let's try again. 0 is moving there. Add 10 is 10. 10 moves across. Sub 10, sub 20 is minus 10. And that moves down. It's not equal to or less than 0, so we move a 0 down there. And this is not equal to 0 or greater than 0. That 0 needs to move right. Okay. I had a hunch it was going to work. Oh, shit. Whoa, wait a minute. It's blocked. Damn. Why is it blocked? It got all the way through until it got to a point. Yeah, there's an edge case here. Okay, interesting. I assume it'll go to the same spot. Yep. So it doesn't like... Huh. Is it the 8 that it gets stuck on, or is it the one before it? It's stuck here, I think. It looks like it hasn't moved anything across the time before this. So if we step it through all the way, sorry about the noise. All right. So I'm moving a 0 down, jump again, move ACC. Oh yeah, the one above it is stuck. This is stuck. It's not going back to its original point. Why not? Move up ACC. Oh, now it is. Move left ACC. Add 10. So we get 0. Move ACC right. That seems to be working. This must be the case before. Minus 20. So now we've got 8 entering. We sub 9. So 9 goes across. But there's nothing. And we're stuck. Oh. So there's a 0 here. We're stuck on move up ACC, but we can't because there's nothing there. And we can't move this because there's nothing here. What is the case that's causing this failure? It's 8 minus 18. $18 is in the back. It's interesting that it works for the first few cases, but not there. All right, let's step through it again and see where we're going. So we swap, move it left, move the up value into ACC, save, sub left, and move ACC right. So the first result is 0, which is fine. Then we get 32. Subtract 0 from it. Move it right. Then we get 30. Subtract 32 from it. Get -2. Move that across. 27. Wait a minute. That -2 shouldn't be in back. So we've had no value that was -2. Oh, but we're going to save it, aren't we? Yeah, we save it. Next value should be +4, I think. Oh, -3, then +4. Yeah. Okay, so we've got 21 coming in. I want to go down a few more. Find where this gets blocked. 23 coming in. The previous value was 21. 21's on the left, 23's just come in. We save it. Then we subtract 21 from 23, giving us 2. And we move that right. Then we've got 19 coming in. $23 goes left. That means it's going to be 23 minus 19, which will be 19 minus 23, which will be negative 4. That moves right. It's going to be 9 minus 19, which would be negative 10. Add 10, move ACC right. So we move 0 right, move left ACC, jump equal to 0 true, move 1 down. So is that correct? Yeah, because it's changed by more than 10. No. 9 to 18. It's changed by 9. So that's actually wrong. Negative 10, add 10 was 0. So that's changed by at least 10, right? Where am I getting hung up? What's going on here? If changed by 10 or more. So 9 and 9 is 18. Oh, but I'm going 9. Yeah, the negative 10 was from here. So it's changed by 10. Jump equal to 0 true, which it is. And we move 1 down. Jump greater than 0 true. We move 1 down. Oh. Do we consume this 0? Maybe that's the problem. Yeah, I bet that's it. Like when we jump, we need to make sure that we unblock the other ports. I think that's the problem. So mov left. Oh, but hang on, we have already, haven't we? Because we mov up ACC, jump greater than 0, true. Ah, no, we don't. Because it's the same number of instructions, they should arrive roughly the same time, I feel like, minus maybe 2 instructions. Or maybe I should process this one first since it got sent last. And then the timing wouldn't matter so much. Let's try it. Take the breakpoint out. No, it stops even earlier. Okay. So this is a timing issue. Where we get left with a 0 that we can't get past. So I need to always clear the port before I continue. So that means we'll go back to doing this. Mov up ACC, mov left ACC. I need to basically have 2 different trues. Up true is mov left ACC, and left true is mov 1 down mov up ACC. This seems really bad, but let's see if it solves the problem first. Nope. And in fact, it's even wrong, which is worse. It's worse than blocking. It's just flat out wrong. Okay. Damn, I'm so close. I'm so close. I should probably take a break. What have I been going 4 hours? Geez. Okay. So that doesn't help the case where I thought that I could clear it. If I was consuming one, then I could clear the other one. Is there a way to discard an output? I guess sub? No. Add, swap, save, move, no up. You can put a label on a line with an instruction. I did not know. What's the comma for, though? Oh, that's actually very useful. I didn't realize you could do that. Can you put... Maybe that's just a typo. But that is very good. I wish I had known that sooner. Okay, we have timing problems. So our solution is not so good. Our solution is not so good. Should I... I have to discard one. Maybe consume both of them. Move up ACC. Swap. Move left ACC. JGZ true. Swap. JGZ true. Yeah, something like that. Where you just forcefully consume both of them. Okay, let's try that. It's better. Aha! Okay, that was it. Oh, thank goodness. I was starting to worry about that one. I definitely don't think it's the most efficient approach. But at least we got there, and we understand a little bit more about absolute value. So you got to subtract by 10 and add by 10. Now, I didn't do too badly. Instruction count was bad. Okay. But yeah, I didn't do too badly. Okay. I need to take a break. This has been a long little stint. So I wonder who's around that we could raid. with my one lurker. Thank you for lurking. I always appreciate a good lurker. Ooh, Mordecai or L colon Q. I never get to raid L colon Q. I'll do that.